with the wet test, no? When
Yes,
it
sir.
comes to the salt analysis, there are
Hmm.
two types of wet test which we have to do. One includes the analysis for anions, the other one is analysis for cations.
Okay.
Anions include anything like halides, F minus, Cl minus, Br minus, and so on. Sorry, Cl
Hmm.
minus, Br minus, and I minus, and so on. Then we can have carbonate, sulfate, nitrite, nitrate, any of these groups. There are few ions which are precipitated along with the cations of the subsequent group in third group reagent because the solution is alkaline nature. So ये वाले सारे you would appear them as a precipitates. What does that mean? While doing your uh, cationic analysis, you would
Mm-hmm.
be noticing these ions as a precipitate. Got it?
Okay.
And based on this precipitates only, we'll try to figure out what was their respective anions there itself, along with the cations. So we do not perform any different test for these anions. Okay.
Okay.
So how we do that, that we will see when we discuss the cationic part. Okay. Hmm. Now,
Right.
other than that, any salt anions which are present, for that to analyze, what we do, we will prepare a solution in water first. Hmm?
Okay.
If we add the salt and try to dissolve it, and if the salt is not getting soluble or it is insoluble, then we make something called a soda extract,
Okay.
which can be prepared by boiling that salt in water along with Na2CO3. So we will take this salt, boil with Na2CO3 in water, and most of the time the metal will take away this carbonate from the sodium carbonate and precipitate itself in the form of carbonates. Okay. Of course, पहले
Okay.
boil करेंगे, फिर धीरे से temperature कम करेंगे, so we will notice that the metal will start, if metal part which is present, that will start precipitating with carbonate. Now the
Right.
anionic part, this is now an ionic compound, right? Sodium के साथ, if you have any ion, that is an ionic compound. Now this ionic compound is soluble form in aqueous solution. So we will filtrate this part. I mean, we'll filtrate this NaX part and then add that with dilute HNO3. Okay. What would
Hmm.
happen is, because we are not sure that there might be still some amount of Na2CO3 present, because you take a small amount of MX and you're not making any quantitative analysis here. You're just taking on your own. Thoda sa, you take maybe a pinch of it and add some amount of Na2CO3 and so on. So there might be still
Okay.
Na2CO3 left in the aqueous solution. So as you dissolve that with dilute HNO3, okay, you try to titrate a bit and see. So then dilute HNO3 will provide H plus, which carbonate can take it and come out as CO2. Okay, it can come out as CO2. Just a minute. Hmm. Okay, okay, right, right. Notice.
Yes, sir.
So the carbon dioxide will escape out. We will get this as NaX. And again, the problem is there might be still some dilute HNO3 left. And that can be neutralized again with ammonia. Okay.
Hmm.
So overall, we will have, you know, ammonia getting escaped here as you start heating. Some amount of NO3 minus might be present. Along with that, some salt ion might be present. And this particular part is what we call it as soda extract. Got it? This is called soda extract. See, NO3 minus हो सकता है ये भी the salt ion is also NO3 minus. Is that clear? So that might interfere with understanding of the ion which we are taking. Clear? So we will do NO3 minus at the end, right? If nothing is happening, other anions are not getting confirmed, then we will do it for NO3 minus. Okay.
Okay.
Now, based on decomposition of anions in acidic medium, we will have two class of anions. Class A is the gases which are evolved when concentrated HCl or concentrated H2SO4 is added. And class B, where there are no gases being evolved. Okay. Furthermore, we will divide this class A into two classes, 1A and 2B, 2A. Got it?
Right.
1A implies that you are getting gases in dilute acids. 2A implies you are getting gases in concentrated acids. Okay. And these ions like sulfate and phosphate, they do not form any kind of gas at all. Hmm? Now
Okay.
notice analysis of 1A. If you are using dilute HCl or dilute H2SO4, got it? You will notice that in case if you have a bicarbonate, okay, if that is your desired anion, then in the presence of H plus, it will become H2CO3, which is nothing but releasing carbon dioxide. Whether it is
Okay.
carbonate or bicarbonate, in both cases, you will get carbon dioxide vapors or gases coming out. If it is bisulfite or sulfite, in both cases, it will become H2SO3, which will start giving away bubbling of SO2 gas. The one difference,
Okay.
physical difference which you will observe between CO2 and SO2 is the smell and irritation in the eyes.
Okay.
Carbon dioxide does not give any smell or irritation, but SO2 will give you irritation in the eyes along with smell of sulfur. Okay.
Hmm.
Next, if you have S2 minus and that is your desired anion in acidic medium, dilute acidic medium, it will give you H2S vapors, which is a rotten egg smell. If you have acetate and that on reaction with H plus or in acidic medium, it will become acetic acid, which will give out the vapors and that vapors will smell like vinegar. If you have NO2 minus in H plus, it will become HNO2 and that further in addition of H plus will convert into N2O5, which will release NO2 gas and O2 gas. Got it? And NO2 gas is a brown color gas. So that brown color vapors, if it is coming out, it confirms the presence of NO2 minus. Okay.
Right.
And if you have a thiosulfate S2O32 minus, that is your desired salt ion, with dilute acids, you will get a colloidal sulfur forming a layer of a dirty white precipitate kind which is forming. Along with that, SO2 vapors will be coming out. So this confirms the presence of thiosulfate. Clear? This is about
Right.
class 1A. So what you need to
Okay.
quickly remember, beta, is this list, that is HCO3 minus,
Hmm.
HCO3 minus, CO3 minus, HSO3 minus, SO32 minus, S2 minus, acetate, NO2 minus, and S2O3 2 minus. These are the ones which belongs to 1A. Next,
Right.
2A. In case if there is NO3 minus, on adding concentrated H2SO4, you would start seeing HNO3, and HNO3 in acidic medium will convert into N2O5, and that on heating will convert into NO2 gas and O2 gas, which is very similar to that of NO2 minus. The only difference here is it will be more absorbed in concentrated H2SO4.
Hmm.
Next, if it is Cl minus in concentrated H2SO4, it will give you HCl vapors. If it is Br minus, instead of giving HBr, it will be giving more amount of Br2. Reason being, concentrated H2SO4 is an oxidizing agent. It would oxidize Br minus into Br2. Okay.
Right.
And now, if you notice the oxidizing ability, chlorine is more oxidizing compared to that of concentrated H2SO4, compared to that of bromine, compared to that of iodine. So that's why concentrated H2SO4 has the ability to oxidize Br minus and I minus. So the logic fits the same for I minus also. Now notice Br2 is a red brown vapors. Got it?
Okay.
HCl is colorless. Hmm.
Hmm.
If it is I minus will give you violet color vapors. Next is oxalate C2O4 2 minus. C2O4 2 minus will give you H2C2O4. Like I said, this is a bit of interfering ion, okay? But yet you can make a confirmatory reaction here. That is, once you get H2C2O4 oxalic acid, you heat it. So one part will convert as carbon monoxide, carbon dioxide, and H2O. So these two gases are a mixture now, imagine. But when you send it, when you burn it on the flame, if it is a blue color flame which is forming, right, that means there is a presence of carbon monoxide. Got it? So carbon
Okay.
monoxide will actually burn as a blue color in flame. Hmm? So which implies that if carbon monoxide is present, probably that is coming from oxalic acid, probably that is coming from oxalate ion. Okay. So quickly reviving, 2A will mainly have NO3 minus, Cl minus, Br minus, I minus, oxalate. Got it?
Right.
Next.
Okay.
Any doubt?
Hmm.
Like I said, phosphate, borate, and sulfate. These three will not give any gases. So that belongs to class B. Hmm?
Right.
If I take analysis of one by one ions, that is HCO3 minus and CO3 2 minus. Now, when you add it with dilute HCl, first it will give CO2. In the presence of BaCl2, it will become BaCO3. Hmm.
Right.
And BaCO3 is a white color PPT. And this white color PPT is what we will analyze through various compounds. On adding dilute HCl, again it will become CO2 and BaCl2. While adding H2SO4, it will become BaSO4. And another important part about BaSO4 is now, if you again add dilute H plus, it will not get dissolved. Hmm? Barium sulfate
Right.
does not dissolve in dilute H plus. With HCN, there is no reaction. With CH3COH, you will get carbon dioxide out and it will become barium CH3COO minus. Okay,
Right.
clear? CO minus. Understood? So that is a soluble form. Now,
Okay.
all bicarbonates are soluble. Carbonates of group 1 are all soluble. Rest of the carbonates are actually precipitates. Okay. And
Right.
carbonates, when you react with calcium chloride, will become calcium carbonate. Bicarbonate with calcium chloride will first become soluble. And then on heating only, it will become carbonate by releasing some amount of CO2 and H2O. Okay.
Okay.
Next, if you notice bisulfate and sulfate, right? On adding with dilute HCl, first you will get SO2. SO2, when you add it with calcium hydroxide, it will become calcium sulfide, which is again a white PPT. And with sulfur dioxide, it will become soluble. And this is exactly the same thing that happens even with, carbonate also. That means if this calcium carbonate is being made, and again, if I add excess amount of carbon dioxide here, so which means if I add HCO3 2 minus in H plus, okay, again, this will become soluble to convert into bicarbonate. So this is a soluble form. So there is no difference which you will find out between sulfur dioxide and carbon dioxide except for
Carbon
the smell.
dioxide.
Hmm?
So it's all physical only, which you can do.
Yeah. But experimentally, if you want to do it, one thing is for sure, that if we take a carbon dioxide form, that is carbonate form, and treat it with K2Cr2O7, there is no reaction. That means there is no color change of dichromate. Dichromate is a orange red color solution, right? So that will not make any color change with carbon dioxide, which suggests that carbon is already at a highest oxidation state. But if it was a sulfur dioxide, sulfur is at +4 oxidation state. It can further oxidize to become +6. So this will get oxidized and it will reduce the chromium part. So this orangish color will convert now into green color. That's a confirmation. That's a main difference that you will notice between CO2 and SO2. Okay. And the
Right.
logic works the same with KMNO4 also, which is a purple color. And as you push it in acidic medium with SO2, it will become colorless, and MnSO4 colorless salt is being formed here. Okay.
Right.
If you react with IO3 minus, IO3 minus will reduce to I2, SO2 will get oxidized to SO4 2 minus. Okay. So these are
Hmm.
specifically redox reactions will happen only with SO2 and not with carbon dioxide. That's the way to differentiate whether it is we are talking about carbon dioxide form or sulfur dioxide form. Next, SO3 minus, when you treat with BaCl2, it will form a white PPT. That on dilute HCl will become BaCl2 and SO2. But here is an interesting fact. Barium sulfide can easily get oxidized in the presence of air, peroxide, dilute HNO3 or bromine. In all these
Right.
cases, it can get oxidized to convert into barium sulfate. Hmm? And barium
Right.
sulfate has an extremely low Ksp value, because of which, if you add it to dilute HCl, okay, if you add it to dilute HCl, there is no reaction happening here. Got it?
Okay.
Hmm. Clear with barium sulfate? Hmm. Any doubt here?
No.
Right. Now notice this one. When it comes to SO3 2 minus, in the presence of AgNO3, first you will get AgSO3 soluble form. Okay. And AgNO3 excess, if you notice, it will become a white PPT of AgSO3. Got it?
Right.
And this, as you starts dissolving with SO3 2 minus again, clear? It will again become the same soluble form. So you will get the ion here. Got it?
Right.
Sorry, twice I forgot, better. Two times here. Okay? Because it is linear complex here. Hmm? So you'll get a colorless complex here, colorless complex here. Okay, but here you'll get a white PPT. So this is one confirmation to say that there is a sulfate present here. Okay. Hmm. Next, sulfide. Sorry. Next is thiosulfate. See, group 1, group 2 are all soluble salts except for barium 2 plus. Okay. Barium 2
Yeah,
plus is
okay.
the only one which is insoluble salt. But group 1, that is group 1, what do you say? Uh, group 1 elements and group 2 elements, all of them are soluble form. Next. Lead, bismuth, mercury, copper, these are all insoluble thiosulfates along with barium.
Hmm.
Okay. Hmm. Next, this thiosulfate, when you add it with dilute HCl, you see that one is precipitate forming, SO2 gas will come and H2O is formed. And this thiosulfate reactions, if you notice, with calcium chloride, it is not going to form any precipitate. But with barium chloride, it will form a white PPT. With lead, it will form a white PPT. And this white PPT on heating with aqueous solution becomes PBS and H2SO4. And Hg2SO3, when you treat with S2O3 2 minus, forms again a soluble complex. This is a soluble complex. Next, if you react with bismuth also, you will get a white PPT, which on hydrolysis will become a black PPT, Bi2S3.
Hmm.
And with copper first it will become a white PPT. If you hydrolyze it, it will become a black PPT of Cu2S. But if you add excess amount of S2O3, it will convert into a complex like this. Okay, C6H2O3 5 times 4 minus. This is the complex form, soluble complex form. Clear?
Right. Okay. Clear.
Sure. Next. What are the other reactions of H2O3 2 minus which we generally see are redox reactions? Okay,
Okay.
that
Yes,
is
sir.
I2 plus I minus. We know that it will become an I3 minus, which is brown color, and that when you react with H2O3 2 minus, this I2 part which is there, it will get oxidized. Sorry, it will get reduced to become 3 moles of this I minus. So it is a colorless solution altogether here, and this brown color becomes colorless. And this is what we call it as iodimetric titrations. And if you directly take I2 also with some starch, so initially it appears blue color. As you try titrate with thiosulfate, it will become a colorless solution, and this is called iodometric titrations. Clear?
Hmm.
Hmm. Next, if you have Fe plus 3 treated with S2O3 2 minus, first it will give a violet color complex, and that on treatment with further Fe plus 3, so this part of iron will get reduced into Fe plus 3, and sulfate will convert or oxidize into SO4, S4O6 2 minus. So the solution which is formed is a green color iron solution.
Hmm.
Most important reaction out of that, out of all the confirmation, is the last one. This is the most important reaction for advanced.
Okay.
That is thiosulfate first. If at all we react that with cyanide, right? So one part is sulfite, which will separate out, but then there is another ion form, which is thiosulfite. Sorry, uh, sodium thiocyanide. So this is thiocyanide, which you will get. So the thiocyanide part will easily get reacted with Fe plus 3, forms a complex. And you can write the complex in many forms. This is one form you can write. Okay. It can be written in multiple forms. You can write it as FeSCN, only one with 2 plus this way. Okay. Just a second.
Yes, sir.
See. So as you could notice, Fe plus 3, when you react with the thiocyanide, you can write it in this format. You can write it in this format, SCN twice with plus here, correct? Plus here. So that iron would be appearing like a plus 3 oxidation state. Or you can write it in this format. In any of this form, they look blood coloration. Okay? Red blood coloration. And they are all liquids only. They are not precipitates. And now, this solution becomes colorless if you add some fluoride salt, because this all complexes will convert into this FeX F6 3 minus complex. Got it?
Hmm.
Question is very nicely integrated with coordination compounds. Got it? Clear, beta? Now you see there will be some I mean this will be kept under
समझ
hidden.
गया.
So this compound के properties पूछ सकते हैं, whether it is paramagnetic, diamagnetic, strong field है, weak field है, right? Octahedral है,
Right.
tetrahedral है, like that. They can keep on asking multiple things about this one.
Right.
Hmm. Okay. Next, let us see about sulfide. Now, group 1, group 2, and NH4 plus, these all sulfides are actually soluble. They are all soluble form. Now, aluminium, chromium, iron, these sulfides do not exist in a soluble form. Okay, clear? So that means they do not, you cannot separate them as easily sulfides, correct? Because the minute you add it to water, it will convert themselves into hydroxides and H2S gas is released. Hmm?
Hmm.
So except for these ions, you will see for rest of them in aqueous solution, sulfides can exist either in the soluble form or in the insoluble form.
Okay.
So H2 minus, when you react with HCl, you'll get H2S, and H2S vapors, right? These vapors directly you pass it through a lead acetate paper. That means you take a paper in which lead acetate is present, then you will see a black color,
Black,
powdered form is formed on it, which is lead sulfide.
Hmm.
Cadmium, if you take it, it will become yellow color. FeCl2, if you take it, it will become a black color PPT. Okay, because iron plus 2 will be a precipitate form, not plus 3. Okay. If you use it with sulfur dioxide, these two will react to form a colloidal sulfur. K2Cr2O7, H2S will get oxidized to colloidal sulfur, and chromium will get reduced to green color solution.
Right.
Check. These are the important reactions of S2 minus. And
So,
S2 minus, as it is, when you react with silver, it will become Ag2S plus black PPT. And in dilute HNO3, it is soluble. But if you do the same thing with mercury, it will first form a black PPT of HGS, and HGS has an extremely low Ksp value in the range of 10 raised to power of minus 50. The range of 10 raised to power of minus 50. Correct? So that means you
okay.
can notice that इसमें hardly कुछ dissociate होगा, right? That's the reason why even by adding dilute HNO3, you will not see any precipitate, any solubility observed. So that means H2S will
Right.
remain as a black PPT. Okay, it only dissolves in aqua regia. Aqua regia is 3:1 ratio of HNO3 and HCl. Okay, sorry, 1:3
Okay.
ratio. 1:3 ratio of HNO3 and HCl. Okay,
Hmm.
right. Next, sodium nitroprusside test. Okay, basically there is a reddish brown colors complex solution wherein iron has a +2 oxidation state. पहले oxidation state को calculate करना समझते हैं. Whenever, remember this, NO is surrounded by other strong ligands. NO is surrounded by other strong ligands. ये याद करने का तरीका है बेटा. If it is
Okay.
surrounded by other strong ligands, usually it will have a +1 charge on it. Hmm?
Hmm.
So अगर ये +1 है, so what is the oxidation state of iron? X
+1.
-5 +1 equal to -2. So that will be equal to +2. Done?
Yeah, +2.
+2 हो जाएगा ना बेटा. X -5 +1 overall equal to -2. तो कितना हो
Yeah, yeah,
जाएगा? +2.
okay.
So iron's oxidation state here is +2. Hmm?
Hmm.
And when you react with sulfide S2 minus, correct? When you
Okay.
react with S2 minus, this NO will become NOS minus now. Sulfide will get connect with this NO plus and convert into NOS minus. So NOS minus ban jayega. So now oxidation state will be X -5 -1 overall equal to -4. X is +2. So the oxidation state of iron is still +2. Here and here it is +2. But NO, which was +1, now it has become NOS with -1. And the color, which is reddish brown, converts into violet color solution. And this is an important confirmation for sulfides.
Okay.
Clear?
Hmm.
Right. Now, this test is not given by H2S, which means you cannot take directly H2S vapors. You have to take the salt itself because we require certain minimum concentration of S2 minus for this reaction to happen. Okay, clear?
So,
Next.
yeah, okay.
Hmm. Next, it is given by H2S in a basic medium though, and it is not given by insoluble sulfides like Ag2S, HGS, COS, NIS. These are all insoluble sulfides. So you cannot just add this salt, sulfide to get this reaction done. Clear with sodium nitroprusside test? Important. Hmm?
Yes, okay, so.
Right, next. We can use H2S directly here with a small composition of H2S is enough with Fe plus 3, and this is N dimethyl aniline. Got it?
Right.
Here. So this form with NH2 on it. Now, when I take 2 moles of this, so what happens here is the sulfur part here, correct? So this sulfur part between the two uh, benzene rings will get connected here. Got it? Between the
Right.
two benzene rings, it gets connected. You will get a double bond here. This is a non-benzenoid form. Okay. So one ring would be benzenoid, the other ring will be non-benzenoid form. And the non-benzenoid form will always be a colored compound. And this is what we call it as methylene blue dye. Okay.
Right.
This is the methylene blue dye formation. And iron, if you notice, which was +3, got reduced to +2. Got it?
Right.
Clear, beta? So iron got
Hmm.
reduced, and carbon is the one which got oxidized. Hmm?
Got reduced and this one got
Clear?
oxidized. Okay.
Right.
Yes,
So
sir.
here you can see this carbon got oxidized. Done? Clear? This you have
Right.
to write and learn. Okay. Unfortunately, this is there in the syllabus. Okay. So you got to learn that.
Hmm.
Next. Nitrite, NO2 minus. See, generally all nitrites are soluble except for AgNO2. So अगर आपने पानी में डाला, that's a easy way of confirming. अगर वो precipitate ही बच रहा है and it is not getting dissolved, that means it has to be AgNO2. Rest all of the nitrates are soluble, any metal nitrite. As you
Right.
add with HCl, it will become HNO2. HNO2, nitrous acid, is an unstable acid. Okay, you shake it for a while, it will start converting into HNO3 and NO gas. NO
Hmm.
gas, it will easily get into an aerial oxidation. That means as soon as it starts connecting, I mean, as soon as it comes into the um, as soon as its vapor starts touching the atmospheric air, so it will start converting itself into NO2 gas, which is reddish brown color gas. Okay,
Okay.
next. NO2 minus, will react with barium chloride. And here there is no precipitate, but with AgNO2, it will become a white PPT. NO2 minus, the oxidation state of nitrogen is +3, so it is still ready to get into oxidation of +5. So chromium will get reduced, NO2 minus will get oxidized. Same happens with KMNO4 also. And with I minus also, I minus in this case will get oxidized. So this will act like a oxidizing agent here. In this case, these are all reducing agent cases. Here it will act like oxidizing agent. And that when you react with I minus will convert into I2, and I2 will start giving a blue coloration in starch. And this NO2 minus will become a brown color vapors of NO2. Clear?
Right.
Now, this is the most important test for NO2 minus, brown ring test. Hmm. Mainly, brown ring test is used for detection of NO2 minus as well as NO3 minus. Hmm. Let's first check out for NO2 minus here. For NO2 minus, as you add this to FeSO4, FeSO4 is a freshly prepared iron. Why we have to freshly prepare is FeSO4, if it is in contact with the air here, Fe plus to get easily oxidized to Fe2O3 and the color changes. So this is a
Hmm.
mild green color solution, FeSO4. Okay, pale green color solution. On that, you add NO2 here. Okay. After adding that, from the walls of this test tube, you start adding dilute H2SO4 or CH3COOH. Okay.
Right.
Now, first NO2 minus will become HNO2. That will give you HNO3 plus NO. As the vapor starts coming into picture here, FeSO4 in this acidic medium, correct, will take away this NO and convert itself into a complex. And you will see here somewhere at the junction where H2SO4, and from here as the vapors will start coming, at this junction you will start noticing a brown color uh, ring formation. Got it? A brown color ring formation. So that ring formation is a confirmation that there is a complex formed here. Now notice here in this case NO is taken to be neutral. This is neutral form, correct? But you might wonder, sir, if it is neutral, then how come iron has, +1 charge? See, it is a 3 electron donor. NO is a 3 electron donor. Got it? So
Hmm.
1 electron, it has already donated it to iron. Got it?
Right.
and other two electrons are being given as a uh, other two electrons are given as a, what do you say, uh, coordination connection, hmm, as a ligand.
Right.
So now iron already has one electron, that makes it X plus 1 charge, hmm, plus H2O as 0, and plus
Yeah.
NO as 0 charge, and overall charge is, plus 2. Correct.
Hmm.
So therefore, when you take this one here, that makes X has plus 1 charge. So iron has a plus 1 oxidation state in brown ring test. Hmm? And of course, it is an unstable form. So immediately, as soon as you shake it, the brown ring is lost, and again iron will get back with another water molecule to form Fe H2O6 with plus 2 oxidation state, like this. Okay, which is colorless.
Hmm.
Got it? Understood? Sorry, not colorless. I mean pale green color. Hmm?
Okay.
So this formation of a ring is the confirmation for presence of NO2 minus. Okay. Next, on analyzing, NO3 minus and NO2 minus can be removed first by making N2 gas. Okay. How do we do that? If if at all we have, let's say, you know, if you are trying to analyze NO3 minus, because NO2 minus is also giving brown ring, NO3 minus is also giving brown ring. So हमको पता कैसे चलेगा कि which is NO2 minus or NO3 minus? So imagine if you are analyzing for NO3 minus, then you need to somehow remove this NO2 minus, right? And you know the disonium reaction, we are just using
Hmm.
the disonium reaction here. That is NO2 minus, when you react with this, uh, when you're reacting with this urea, right? So this is the
Right.
urea part. You can notice that this NH2 is present in the presence of H plus is HNO2, and primary amine and HNO2 will make a disonium salt, correct? So here also you'll get N2,
Primary
here also you'll get
amine
N2.
and HNO2 will make
Just
a
recall from
yeah. Correct,
organic
correct, huh?
part,
Correct, correct, correct. Hmm.
RNH2, it will give
Correct, correct. I
in the
remember,
presence
yeah.
of, yeah. So I'll just write it anyway here, Rn2 plus. And you know that N2 is highly unstable, it will become carbocation plus N2 gas, correct?
Right.
The same thing we have trying to check here. So N2 gas will go away, and this part will convert into carbon dioxide, okay, on hydrolysis. Clear?
ठीक है.
Like this way, you can remove out this NO2 minus. Okay.
Right.
अच्छा मैंने नीचे लिखा है, sorry. Okay. Now, notice it, sulfanic acid. This is sulfanic acid, and sulfanic acid also has NH2. So again with
Right.
NO2 minus, N2 gas will come out. This will become H2SO4. Okay. So therefore, other ions which interfere during the brown ring test, other than NO2 minus, which are the cases? We can have
BR
Br
minus and
minus and
S
I
minus.
minus also.
I minus.
Okay.
So, so,
Hmm.
so एक मिनट मुझे वॉशरूम यूज करने दो.
Yeah, sure.
Oh, Tuesday, see Tuesday.
Fifth,
Oh,
there
no,
is
acha,
fifth.
oh wait, I forgot. Our school celebrates it 10 days early.
Okay, okay. So now notice this one. This, just like I told you, it is unstable. In the presence of O2,
Uh-huh.
it will become FeSO4, and this NO gas will convert into NO2. Okay,
Correct.
right. Now, next notice acetic acid, I mean acetate ion. Silver,
Hmm.
mercury salts are insoluble, rest all are soluble here. Hmm? Only
Right.
silver is a white PPT, and mercury is also that white PPT form. CH3CO minus, when you react with methanol, so that will convert into an ester, which is going to give you a fruity smell. So that is a confirmation that it is an acetate group. The main confirmation in this, which recently asked in JEE mains also, is this one. If you treat with FeCl3, okay, this acetate form will convert into red color solution, which Fe3 CH3CO 6 times and OH twice. So remember the complex beta. इसमें just रटना है. I can't do anything about it. So this is a complex which is formed, which is the red color solution. And if you keep it long standing or slightly heating, this entire complex will convert into a red color PPT now. So the PPT now will have
Uh,
hydroxide and one acetate form. Hmm?
so red solution will turn to red PPT in
Hmm.
CH3CO minus. Okay. Hmm.
Done? Right. So this is what would happen here. Okay. Done?
Right.
Next. This is about two-way radicals. So I think, 1 second, just give me a pause. Yeah, sorry. Now notice this one. When it comes to NO3 minus, NO3 minus, yeah. When it comes to NO3 minus, as you react with concentrated H2SO4, first it will become NO2 and O2 and H2O. That's a confirmation. All nitrate are water soluble, no precipitates are observed with nitrates. And if you treat with copper here in concentrated H plus, it will become copper nitrate plus NO2. So copper will get oxidized, NO2 will get, NO3 minus will get reduced to give brown color vapors. Now, how the brown ring test form? Now, this time we take some concentrated H2SO4, not dilute. Earlier, with for NO2 minus, we took dilute, but here we need to take concentrated H2SO4. So,
Right.
NO3 minus with concentrated H2SO4 in the presence of Fe plus 2, Fe plus 2 will get oxidized to Fe plus 3, and NO3 minus will get, formation into NO. Got it? So, it gets reduced
Right.
into NO gas and sulfate will form. And Fe plus 2 will then react with these NO vapors, convert into a brown ring complex. Okay. Now here the interfering ions includes Br minus, I minus, chromate, ClO3 minus, NO2 minus. All of these are interfering ions. Clear? So we have to somehow liberate them before making reaction for NO3 minus. Correct? See, halides liberate halogen gas, that is I2. I2, Br2, those are all brown color or violet color vapor, so which will interfere, right? That will not be able to clearly make out which is the gas which is giving any vapors in this reaction. Okay. Chlorate will also give you ClO2 which is colored. Okay. ClO3 which is colored. NO2 minus will give you NO2 which is brown color. CrO3 2 minus will give you CrO3 which is red color vapors. I2 is violet. Bromine is red color vapors again. So it is going to interfere with it. Got it?
Right.
So again, notice that ClO3 which is formed and ClO3 will dimerize to form a red color vapor here also. Okay.
Okay.
Now, to check out the presence of NO3 minus, what we can do, we can use, copper, aluminum, zinc alloy, which you call it as they were the alloy. That alloy will easily provide H plus ions in basic medium, OH minus. Not H plus ions, radical hydrogens or nascent hydrogens. That will reduce the NO3 minus into ammonia. Okay. And the vapors of ammonia, if you pass it through dilute HCl vapors, it will give you white color fumes. So that white color fumes confirms the presence of NO3 minus. Got it? So with
Hmm.
zinc, directly I can use zinc in basic medium also to get ammonia, or aluminum in basic medium also to get ammonia. Got it?
Right.
Right. These are the reactions for nitrate NO3 minus. Next is Cl minus. See, in case of Cl minus, first check it out. Mercury 2 plus, Ag plus, Pb2 plus, copper, Cu2 2 plus, these are all insoluble salts. Okay. They all will form
Right.
insoluble salts. Generally, all of them are white color. Cl minus, when you react with concentrated H2SO4, you'll only get pungent odor of HCl vapors. And Cl minus, directly when you react with MnO2, MnO2 is a very good oxidizing agent in acidic medium. It will convert into Mn plus 2 and Cl minus will convert into Cl2. With AgNO3, first it will become a white PPT, and this is the most used conformation here. And AgCl will, when you react with concentrated HCl, will become a soluble complex. With ammonia, it will become a soluble complex. S2O3 2 minus, it becomes a soluble complex. With cyanide, it will become a soluble complex. Correct?
Right.
ये रिएक्शन सीक्वेंस वाइज ही याद रखना, बिकॉज इसी सीक्वेंस को हम लोग बार बार पढ़ेंगे. ओके, one for chlorides, one for bromides, and one for iodides. Okay.
Right.
Next, if you react with lead acetate, you will get a white color precipitate, which on slightly heating, it will tend to become soluble again. Lead, happens to form precipitate with chloride, which is PbCl2. But just as you heat the solution, that precipitate will dissolve in that solution. Okay, so it will become
Right.
a soluble form. Correct. Now there is one important test for chlorine, which I think I have written it at the end here, which is chromyl chloride test. Correct. That
Right.
I'll check it out where I have written it, but I'll discuss it once. Okay. Mm. That is one important test for chlorides. Now notice Br minus. Br minus also is forming an insoluble salt with these ions. And Br minus, when you react with concentrated H2SO4, we learned that it gives bromine gas instead. And Br minus, when you react with MnO2, will also become bromine gas. Mn plus 2 will form. Now check out the same reactions. Whatever I have done with chlorides, I'm doing the same with Br minus. With AgNO3, first it will become a yellow color PPT. And with concentrated HBr, sorry, here it is forming. With concentrated HBr, it is forming a complex here, that is HAgBr2. This is a complex which it forms. But with dilute ammonia, there is no complex. It
Right.
requires a concentrated ammonia to form a soluble complex. That's the first difference you got from chloride and bromide form. Okay? There we require, even if you give dilute, it get dissolved. But for bromine, we require concentrated. Hmm? Like
Right.
S2O3 2 minus will anyway make a dissolution, and cyanide will always make a dissolution. Hmm? And
Right.
same logic, PbOAc, it will give a white PPT just like chloride, and on heating, it will become soluble. But temperature T2 is slightly, sufficiently higher than T1. Okay.
Right.
Iodide. In case of iodide, again, mercury, silver, Hg2 plus also, Pb2 plus, Cu2 2 plus. All of these are forming insoluble iodides. And as you react with concentrated H2SO4, it will form I2, and I minus will also get oxidized to I2 in the presence of MnO2. And as you react with AgNO3, first, this one is again wrong, HgAI2. This is the complex which is formed, okay, which is soluble. But with ammonia, whether you take dilute or concentrated, ध्यान से देखो, dilute or concentrated, no reaction. Okay, could you remember the difference now? Chloride dilute में dissolve हो रहा है, ब्रोमीन concentrated में dissolve हो रहा है, आयोडीन दोनों में नहीं हो रहा है. Got it?
Right.
Nice. In H2O3 it will get dissolved, in cyanide it will get dissolved. Okay. And now notice this one. I minus, when you treat with PbOAc, it will form yellow color PPT. Unlike white color with PbCl2 and PbBr2, it is forming yellow color PPT. And that again on heating strongly, it will get dissolved. And as you start cooling it, now this time the crystals will form within the, it's not like they'll settle down. Immediately within the solution, wherever they are vapors, wherever there is in a dissolved form, as it will start precipitating there itself, and you will observe as if nicely all the gold flakes are being dissolved in that solution, so as if all the gold flakes are moving around. So those are called golden yellow sparkles.
Golden yellow sparkles. I know I've seen these.
Hmm.
There's silver sparkles also, something.
Yeah, silver sparkles also you'll see. Okay.
Hmm.
That is in Tolin's test. Okay.
Ah, yeah, correct.
Hmm. Right. So overall, if you notice the temperature, T3 is greater than T2 greater than T1. ठीक है बेटा. So इस sequence
Right,
में पढ़ना, it becomes easier to compare and where exactly what is happening. Okay.
right.
Right. Next, layer test. Layer test is about making, you know, chlorine Cl2 as an oxidizing agent and trying to oxidize Br minus to Br2, I minus to I2. Okay. So how does this help? How it helps is bromine whenever it is present in CCl4 or CHCl3. Chloroform, you can take chloroform also, you can take CS2 also, or you can take CCl4 also, any of these three solvents. Okay. And
Hmm.
that particular solvent is called organic layer. Hmm? In
Right,
organic layer, bromine will appear reddish brown, iodine will appear violet. Okay.
right.
So initially, imagine I took an aqueous solution which will have a dissolved bromide or iodide. Let us say start with bromide. Okay. And then you are adding chlorine, Cl2, in the presence of H2O. Okay. Right. So chlorine water you are adding. So what will it do? It will start oxidizing that bromide into Br2. Then you add this organic layer, this organic layer, which is colorless. CCl4 is colorless, CHBr3 is colorless, CS2 is colorless. As you add it, now that organic layer will start turning into different colors. If it becomes reddish brown, it means you have released bromine. If it is violet color, it turning into violet color, that means you have released iodine. Okay, this is called layer test. Adi clear it.
Right,
Generally for fluorides and silicates and all, what we need to check. See, fluorides, all of them are usually soluble. Okay. F
Hmm.
minus with concentrated H2SO4 will become HF. HF when you react with silica will form SiF4, and SiO4, if you keep it on a moist glass and leave it for some time, you will start etching of the glass. The glass will start having an etching. That is because the glass will react with SiF4 to convert into H2SiO3 and H2SiF6, which is soluble form. Okay. This get a slight deposits on the surface, but this will become a soluble form. So you'll see the etching of that. Instead of smooth surface, now you'll have all the etchings on glass. And that's the confirmation for fluoride. But again, this is not a part of your syllabus, so don't worry about it.
Right,
Next, oxalate. You know that group 1 and ammonia are soluble, other oxalates are generally insoluble. Okay.
right.
Now, oxalate, when you react with concentrated H plus, it will give, carbon monoxide and carbon dioxide. Carbon monoxide can reduce palladium chloride into black color palladium, and carbon
Okay.
monoxide in red, reducing flame, will burn as a blue color. Hmm? Okay.
Right,
And next, if you have oxalate, we know that KMNO4, K2Cr2O7, MnO2, all of them will help it getting oxidized to carbon dioxide. And we have seen this in redox reactions. Yeah. Oxalate with calcium will form precipitate, white PPT. Strontium will form, barium will form white PPT. But notice calcium does not dissolve in acetate, strontium does not dissolve in acetic acid, but barium oxalate will dissolve in acetic acid. Okay. This is the only exception. Usually down the group, the Ksp value decreases except for oxalate. Hmm?
right,
Oxalate are the only case where the Ksp value for group 2 actually increases down the group.
right.
Done. Borates. Borates are a part of syllabus. How they can be asked? Let me tell you. If you have BO3 3 minus, if you treat with concentrated H2SO4, first you will get boric acid. Boric acid is not coming as vapors, but the minute when you add methanol to it, it will convert into an ester form, like esterification. Acid and alcohol becomes an ester. So this is called borate ester, BOCH3 thrice. And borate ester is volatile. So as you start heating, it will vapors will come, and that vapors, if you pass it through oxidizing flame, on an oxidizing flame, it will give a green edged flame. So that green edged flame is a indication that what we are using is a borate,
Right.
right? Next, borate, when you treat with calcium fluoride in the presence of concentrated H2SO4, it will become BF3 vapors, and BF3 are volatile vapors, and oxidizing flame, it will give you green color vapors. Done. Next,
Okay.
group 2, group B are not there in the syllabus, but just in case, for advanced point of view, just make a note of it. That's it. So silicate, when you react with calcium fluoride, becomes SiF4. SiO4 can be conformed on a moist glass rod. Correct.
Right.
Next, phosphates. Lithium phosphate and silver phosphate are insoluble forms, but rest all are soluble. So with silver phosphate, it will become a pale uh, yellow color precipitate. Got it?
Oh,
Phosphate with ammonium molybdate, ammonium MOO4, it will become a yellow color PPT, canary yellow color PPT formation. Okay.
okay.
Or phosphate can also be used with magnesium salts. So in the presence of basic medium, mild basic medium, so you can get this formation into white PPT, which is magnesium ammonium phosphate. That on slightly heating will convert into magnesium, uh, you know, pyrophosphate, which is P2O7. So this is a white PPT. In fact, this reaction is the confirmation for magnesium 2 plus also. मैग्नीशियम 2 प्लस के लिए भी यही कंफर्मेशन है, फॉस्फेट के लिए भी यही कंफर्मेशन है. ओके.
Sir, one second, sir, information overload हो रहा है, sir.
या लास्ट
Pause,
दिस
pause,
इज द
pause.
लास्ट वन.
PO4 3 minus P MgCl2 NH4 OH NH4 Cl6 MgNH4 PO4.
Unfortunately this has less logic and more, information.
I can tell. Not gonna go well for me. Uh, so that, and then उस पे heat किया तो Mg2P2O7, which is a white precipitate, plus NH3 gas plus H2O gas. So बाहर से when you perform तो white will remain white only. The only new thing which will happen is कि NH3 gas आएगी बाहर.
या
When you perform बाहर से.
या
ठीक है, okay.
डन.
Right.
या नाउ नोटिस sulfates. Any of these forms insoluble salts of sulfates. In fact, sulfates, barium is the best one, and I told you that for barium, as you start dissolving in dilute H plus, it will not get dissolved. So that's the confirmation that it is a sulfate form. Hmm? Yeah, beta. Right. So this is all
Right.
about the anions. So whatever we discuss is all about anions. Clear? The
Right.
next part is all about cations as well as the heating effects. See, generally, if you have oxides, carbonate, bicarbonates, sulfates, nitrates, on heating, what will be the products? So this is that basic equations. Okay. This we will have to practice together. You have to write, I have to write. That way, if you keep doing it, it will become easier to remember. Okay.